Hey guys, welcome to this tutorial. This tutorial is focused on the rotation. So we basically have a problem here that we want to solve. The question is the following: find a matrix A that represents clockwise rotation in R3 by pi over 4 about the line passing through the origin in the direction of this plane. Okay, the question of the plane is given here. And I just sketch here, this is a representation, kind of representations of this plane, x plus 2y plus 2z is equal to 0. So what happened is, if you want to do a rotation of pi over 4, we know by definition that the matrix A is Q times R times Q transpose. This is what we know by definition, right? All right. We don't know what is Q. We know that Q is an orthogonal matrix, and this is a rotation matrix. And also, by definition, the rotation matrix is cos theta minus sine theta, and cos theta. And this is 0, 0, 0, 0, and 1. All right, we choose the rotation to be with respect to this z-axis. So we have to define a new frame. This is capital X, capital Y, and capital Z, such that this capital X is in the plane, capital Y is also in the plane, and let's call this one capital Z is orthogonal to the plane. That's why, and we want to do the rotation here with respect to Z. That's why, if you remember when I defined the matrix, the rotation matrix, when we have 1 here, it means that the rotation here is with respect to the Z axis. So we want to know what is Q now, the orthogonal matrix, because from here, we are lucky because we are giving the angles of rotation in this question. If you substitute here, you have R is just cos pi over 2 is 1 over root 2. This is minus 1 over root 2. This is 0. 1 over root 2. 1 over root 2. 0, 0, 0, and 1. This is what we obtain. So for the orthogonal matrix Q, we choose the first vector from this orthogonal to this plane. So let's take U3 is equal this vector 1, 2, 2. So I'm just using the coefficients I have in front of each term here, x, y, and z. And secondly, let's choose u1 in the plane, in this plane. U1 is, if we take u1, the first entry is 0, 1, and minus 1. This belongs to the plane. And for u3, for U2, it's just a cross product. Given that U1, U2, and U3 have to be orthogonal to each other, and I know that U1 and U3 are already orthogonal, then I want to define U2 in such a way that U2 will be orthogonal to U1 and orthogonal to U3. So to define such matrix, I can just take a cross product between U3 and U1. Okay, so this is U3 is 1, 2, 2, cross product. U1 is 0, 1, and minus 1. If we do the cross product here, we first cross the first entry, we remain with minus 2, minus 2, minus 2. This is minus 4. The first entry. The second entry, we cross the second entry here. We remain with this time. This is minus 1. And the negative sign coming from the formula, this is 1. And the other one is 0. So we cross now the last entry. Okay. The last row, we remain with 1 times 1 is 1. Minus 2 times 0 is 1. So this is what we have. This is the vector U2. We have U1, U2, and U3, okay? So what's happened here is these vectors have to be orthonormal. What does orthonormal mean? Orthonormal means they have to be orthogonal to each other, and it should be formed with the unique vectors. So can we say that this is a unique vector? This is not a unique vector because the norm of this vector is not 1. So to make sure that the norm of this vector is 1, we have to scale this vector in this way. If I call it u3 hat, this is 1 over 3 times 1, 2, 2. So if we find the norm of this, we find that it's 1. Here is the same. u1 hat is 1 over 2. This is 0, 1, and minus 1. And for the last one, this is u2 hat is 16. 4 square is 16, 17, 18. So 1 over square root of 18 minus 4, 1, 1. All right. We have u1, u2, and u3. Then we can write down the orthogonal matrix. Q is now given by this. First entry should be u1. So u1 is 0, 1 over root 2, and minus 1 over root 2. The second one is u2. This is minus 4 over root 18, 1 over root 18, and the last one is 1 over root 18. The third vector is 1 over 3, 2 over 3, and 2 over 3. All right. We use this formula. We know that A is Q times Q, R times Q inverse. So this is Q is given here. So we take this matrix Q. This is 0 minus 4 over root 18, 1 over 3, 1 over root 2, 1 over root 18, 2 over 3 minus 1 over root 2, 1 over root 18, 2 over 3. If we multiply this, we consider this part, right? We take this matrix, and we multiply by the rest of this matrix. It gives us this part, minus 2 over 3, minus 2 over 3. So this comes from this part. And then if you multiply these two matrices, you end up with the following. A is equal 1 over 9. All right, here if you multiply these two matrices, then you obtain this. This is the matrix A. Remember that my objective in this is not to show you how to do the matrix multiplication. That's why I have to skip this part and I just give you this final result. So you should be able to know how to multiply two matrices or three matrices based on the previous chapter, right? All right, this is all for this exercise. Thank you.